All right, so we're going to take a look at a few more examples here, and then we will have some practice work at the end of this video. So in this problem, we're looking to find y and z. In the last problem of the last video, we had a 45, 45, 90 triangle, and we talked about some ways that we could solve and try and figure out, I believe, x in that video. Here, we don't have as many options. I can't just use the Pythagorean theorem. Pythagorean theorem would require me to know two sides, and I only know one. I know the side 9. We could go through our rules for 30, 60, 90. If we go back to the old videos, just a handful of videos ago, there is a video for 30, 60, 90 triangles, and we had a problem just like this. And you could totally do the problem in that fashion. There's nothing wrong with that. That requires a little more memorization than this. This one still is going to require some memorization the way that we're going to go through it. So you kind of have options, right? It's what do I want to be the master at? Do I want to be the master at knowing the rules for 30, 60, 90 triangles? If you recall, what that looks like is we create a triangle like this. I'm going to draw it just like this one, where this is the 30 and this is the 60 and here's the 90, right? And we know that the small side is x. We know that the hypotenuse is 2 times x. And we know the longer leg is the square root of 3 times x, right? We can memorize that and use that. That tends to be difficult for a lot of students, and so I don't recommend doing this problem in that fashion, so I'm just going to get rid of that there. I don't like memorizing the 30, 60, 90, 45, 45, 90 things. I like using trig instead, but trig makes sense to me because I've used it a lot, and that's the only difference between me and you. I use this stuff a lot because I do it, I teach it, and I practice it. The more practice you get just as good as me. There's nothing special. Just because I'm a teacher doesn't mean I hold any special things or I'm better than you in any way. You can memorize things just like I do. You just have to put in the time. The difference is I like math because I'm crazy. That's what makes it easier for me. All right. So if we're looking at this, we can focus on the sines and the cosines and the tangents of things. So what I'm going to do is I'm going to focus on the 30-degree angle. I get to choose. You could choose either one. Some problems you can choose and some you can't. It just kind of depends on what information you have. So what I'm going to do is I'm going to focus on the 30-degree angle. If I'm focusing on that 30-degree angle, then I can label the sides based on that angle. Now, one side that's not going to change, this side right here, y, is definitely the hypotenuse. I don't know why I use yellow. Let's get rid of yellow. It's so hard to read. Let's switch over and let's go green. I can read green so much easier. So based on that 30-degree angle, we know that y is going to be the hypotenuse no matter what. I don't care if you pick the 30-degree angle, the 60-degree angle, or what you can't do. You can't pick the 90, but even if you did, y is still the hypotenuse. It's always the hypotenuse. That's not going to change. But based on the side you pick, you could have an adjacent side or an opposite side, and those can flip-flop depending on if you're focusing on the 30 or the 60-degree angle. You never focus on the 90. Based on the 30-degree angle, my side that's labeled 9, that's the opposite side. That is directly opposite the 30-degree angle, which leaves my other side, my other missing side, the side that's labeled Z, that's going to be the adjacent side. Now, this only applies if I'm focusing on the 30-degree angle. If I were to switch midstream during the problem and decide to start focusing on the 60-degree angle, the word adjacent and opposite would have to be thrown away. Hypotenuse can still be there. Hypotenuse doesn't change, but adjacent and opposite change based on what angle you're looking at. So if you decide to switch an angle, it's fine, but then that means your words adjacent and opposite need to change as well, so be aware of that. Since I'm focusing on 30, I should be good to go. I can do sine, I can do cosine, I can do tangent. We know the definitions for all of those. I'm going to start with the sine. And so I've got the sine of 30 degrees. Remember, when you do sine, we abbreviate the word sine, the operation sine, with just the 3 letters, S-I-N, but you have to put an angle after it, either an angle letter that represents an angle or the actual measurement. I'm going to put the measurement, the sine of 30 degrees. Now, according to our knowledge of this trig, go back a few videos. We've got about 4 videos now that deal with trig, so go back to the beginning and look at trig. Sine is equal to the opposite side divided by the hypotenuse. So when I look at this picture, the side opposite the 30-degree angle, we've got it labeled. That's 9. The hypotenuse, we've got it labeled as well. That's the letter y. And so I know the sine of 30 has to equal 9 divided by y. Now, here's where the trig comes into play, and something that you're going to do. We're probably going to do one more video on trig after this. You can actually grab your calculator and type in the sine of 30 degrees. If you're using your phone, you just simply have to turn your phone sideways, and you will see all three trig ratios there: sin, cos, and tan. Okay, all you have to do, I believe, well, I have my phone right here, and so while I'm talking to you, I will grab my calculator, and when you type it on your calculator, you just hit sin. It's down in the lower left-hand corner, but you have to type the angle first. So you type in 30, and you hit sin, sine, and it'll tell you what that ratio is. Now, it doesn't tell you as a fraction, instead it tells you as a decimal, and it says that it's 0.5. We know that 0.5 means 1/2, right? And so you could either write 0.5 here, or you could write 1/2. It's totally up to you. Just for funsies, let's go ahead and go with the decimal. And so the sine of 30 degrees, instead of writing it as 1/2, I can write it as 0.5, or just 0.5 if you like. That's going to equal 9/y. We still have to solve for y. We can still cross multiply. Whether I write this as 0.5 or whether I write it as 1/2, either way I can change that into a fraction by putting it underneath a 1, or putting a 1 underneath it, and then we can cross multiply. So when I cross multiply, 0.5 times y is 0.5y, and 9 times 1 is 9. And then to solve for y, we have to divide by that 0.5. Now here's where it can be tricky. If you divide this in your head, you might end up getting it wrong. Let your calculator do the work. You're not dividing by 2, you're dividing by 1/2. When you take 9 and divide it by 1/2, you get 18. This kind of verifies the fact that the sine of 30 has to be in a ratio of 1/2, right? If we look at the ratio, the opposite side divided by the hypotenuse, 9 divided by 18 is 1/2. See, that relationship holds true. Okay. Now when we go to z, we have choices. We can stick with the 30-degree angle. We can move to the 60-degree angle. I don't recommend moving unless you're forced to. We're not forced to here. So I'm still going to stick with the 30-degree angle. I can either go with cosine, or I can go with tangent. I can basically do either one. If we decide to go cosine, the cosine of 30 degrees, that's going to equal the adjacent side, which is z, and that's what I'm looking for, divided by the hypotenuse, which is y. Now, if I just put y here, I'm kind of stuck. You can't do anything with this. You have two variables. However, if we look back to the we just completed, we know what y is. Y is 18. So once you figure out a letter, you can put that number for that letter every single time, as long as you're not changing the problem. Now, we can go through this one of two ways. If decimals are not okay, then we need to have memorized the cosine of 30 degrees. If you go back to the last video, the cosine of 30 degrees we figured out is always equal to the square root of 3 divided by 2. That's going to equal z over 18. To solve this, we can cross multiply. We can multiply 2 times z to get 2z. That's going to equal the other product, 18 times the square root of 3, which is just 18 square root of 3. You can't put those together. And then when we solve this and divide both sides by 2, we get z is equal to 9 times the square root of 3. Yay! Now, let's say that decimals are cool. If decimals are cool, then what I can do is I can just grab my calculator. I didn't mean to do that. I can just grab my calculator and type in 30 degrees and hit the COS button. And so if decimals are okay, then when I hit that on my calculator, I get 0.866. It keeps on going. We're just going to write it as 0.866. No need to write all the rest of the decimals. That would equal z divided by 18. Again, I could put that 0.866 over 1, and now if I cross multiply, 1 times z is z, and if I multiply 18 times 0.866, we end up with 15.588. Now, if you grab your calculator, if you were to punch 9 square root of 3 on your calculator, guess what the decimal's equal to? OMG, it's equal to 15.588. 8. It's like magic, but it's not magic, it's math, because that's how math works, right? And so we end up getting that decimal or that non-decimal. It just kind of depends on the directions. Most math teachers, especially as you go higher and higher up, at Math 3, pre-calculus, calculus, I can tell you as a pre-calculus and calculus teacher, we teachers prefer, we math teachers anyway, prefer the decimal. I know that that makes you sad. You want us to prefer the 9 radical 3, not the decimal. You want us to prefer the decimal. Sorry, we tend to not prefer the decimal, which means that you have to have this cosine of 30 memorized as the square root of 3 divided by 2, because when you punch it on your calculator, you're not going to recognize that that decimal is the square root of 3 divided by 2, even though it actually is. And so you need to memorize these things because you're usually going to be asked to find the exact value, not a decimal equivalent. But this is how we go through and do these. Now, if we don't have these memorized, we just do the decimal. So one last quick example, we're going to see more of these in my last video on trig, but let's say that we had something like this triangle, 90 degrees still, you have to have a 90-degree angle, and let's just throw in a number here, just a random number, not one that we have memorized. Let's say that this angle is 21 degrees. Okay, and then to throw in some other numbers, let's call this x and let's call this 10. If I were looking for x in this problem, we can still do it, we just can't do it with memorization. See, I can still set up my trig. If we focus on the 21, if we do sine, remember we have to put, motorcycle going by, we have to put the angle after sine, so we're doing 21 degrees, so the sine of 21 degrees would equal the opposite side measurement, which is x, divided by the hypotenuse measurement, which is 10. Now, nobody, at least nobody that I know, has the sine of 21 degrees memorized. I have the sine, the cosine, the tangent of 30 and 45 and 60 because those are common. Sine of 21 is not common. So what we do is we just grab our calculator. It would be just as if we had it memorized. If we memorize the decimal, then we'd be good. The sine of 21, turns out when I do it on my calculator, is 0.358. Okay, no problem. Now that we have that, we can just multiply both sides by 10. Let's do that in a different color. We can multiply both sides by 10 and get our answer. And when we multiply both sides by 10, we get that x is equal to 3.58. Okay, now this works exactly the same as the last problem where we had things memorized. The difference is we memorize the square root of 3 over 2. We don't memorize that the sine of 21 is 0.358. But if we did have that memorized, then we would just write that down. Fortunately, we have a calculator that we can calculate all of these trig measurements on, so we don't have to really worry about memorizing too much. But if you plan on going to calculus, in calculus we have the AP test and there's no calculator for half of that test, which means you have to have that stuff memorized. It's just like memorizing multiplication tables or anything else. Through practice you can easily memorize it. So let's go ahead and practice some problems. For these problems, they're all going to deal with 30 degrees, 60 degrees, and 45 degrees. So I don't want any decimals on these answers. These need to be exact answers, square roots of 3 and 2 and things like that. So this is going to happen on page 465 out of your book. We're going to do problems 7 through 13, problem 16, and then problems 21 through 35. So work on those problems. Make sure that you complete every problem and complete it thoroughly. If it's not incorrect type of work, if it's just random stuff, I won't give you credit. If you're missing problems, I won't give you credit. But if you do all of those problems with decent work, right or wrong, you'll get credit, and you get a 10% grade bump as long as all of the assignments are complete. So work on that assignment, and if you have problems, send me a text via Remind. Otherwise, until our next video, have yourself a great day.